Hey everyone, you know when you write your Java code and hit run, ever wonder what actually happens? Like, where does everything go? Well, today we're pulling back the curtain on the Java virtual machine, and we're going to explore its memory map. Let's get right into it. So think about it. You write your code, you run it, and poof, it works. But where do all those little pieces, that int variable you declared, or that calculator object you created, where do they actually live inside your computer's memory? That's the big question, and that's exactly the puzzle we're going to solve together today. Okay, so the stage for all this action is a special place called the Java Virtual Machine, or JVM for short. The easiest way to think about it is like a little self-contained world just for your Java code to run in. And inside this world, the JVM has its own strict rules about how it manages memory. And believe me, the JVM is super organized. It doesn't just throw all your variables and objects into one big, messy junk drawer. Nope, it carefully sorts everything into two primary areas, the stack and the heap. And I promise you, understanding the difference between these two is the key to really getting how Java memory works.
All right, let's start with the first one, the stack. I want you to think of the stack as your program's short-term memory. It's built for speed, it's super organized, and its whole job is to handle the things that are happening right now.
So what kind of stuff lives on the stack? Well, it's the home for all your local variables, the ones you declare inside of a method. And the stack operates on one super simple but really important rule: last in, first out, or LIFO. It's literally like a stack of plates at a buffet. The last plate you put on top is the very first one you're going to take off. Makes sense, right?
Let's look at this in action. It's so simple. Imagine we push the number 5 onto our stack. Then we push 6 right on top of it. And finally, 7 goes on top of that. Now here's the key. If you want to get a value out, you can't just reach down and grab the 5 at the bottom. No way. You have to take the 7 off first. The last thing you put in is always the first thing you take out. That's life.
Okay, so plates are great, but how does this apply to our actual Java code? Well, it's pretty cool. Every single time you call a method, Java creates something called a frame for it and pushes that frame right onto the stack. So when your program kicks off, the main method gets its own frame. Then, if your main method calls, say, an add method, a brand new frame for add gets stacked right on top of the main frame. And inside each of these little frames is everything that method needs to do its job. It's like its own little toolkit. You've got its local variables like int data equals 10. You've got any parameters that were passed into it like n1 and n2. And you have something called a reference variable. Now hang on to that thought, because that little guy is a huge piece of this puzzle, and we're going to come right back to it.
All right, we've got the stack down. Now let's talk about its partner in crime, the heap. If the stack is for quick, temporary, here and now stuff, the heap is, well, it's the opposite. Think of it as a huge, sprawling warehouse for the bigger, more permanent parts of your application.
The heap has one main purpose. It is the designated home for every single one of your Java objects. You know that new keyword you type all the time? New calculator, new string. Every time you use new, you are literally telling the JVM, hey, go find me some empty space in that big warehouse, the heap, and build me a new object right there.
This leads us to a super important distinction you have to get right. Variables you declare inside a method, those are local variables, and they live on the fast temporary stack. But variables you declare inside a class, but outside any method, those are instance variables, and they live on the heap, tucked away inside their object. It really all boils down to one thing. Where did you declare it?
Okay, so we have the stack for our fast, local stuff, we have the heap for our big objects, but here's the thing, they don't just ignore each other. They're not two separate islands. The real magic, the part that makes it all work, is how they're connected. Let's see how they talk to each other.
Now, if you remember only one thing from this whole explainer, let it be this. When you write calculator obj equals new calculator, that obj variable, it is not the object. I'll say it again. Obj is not the object. It's just a reference variable. Think of it like a remote control for your TV. The remote isn't the TV, it just points to it and tells it what to do.
Let's break down exactly what happens when you create an object. First, the part on the right, new calculator, tells the JVM to build an actual object in the heap. The JVM finds some space, builds it, and gives it a unique address. Let's say address #101. Inside that object is where its instance variables live. Then, the part on the left, calculator obj, creates a variable on the stack. And what value do we put in that obj variable? We put the address, #101. So the stack holds the address and the heap holds the actual house. The stack variable knows how to find the object in the heap.
Okay, theory is great, but let's prove it. Let's see this in action. If these objects really live separately in the heap and all we have are these remote controls on the stack, what does that mean in practice? Time for a little experiment.
So here's the setup. We're going to create two completely separate calculator objects. That means two objects in the heap and two different references on the stack pointing to them. Then, we're only going to change a value in the first object. The big question is, does messing with the first object do anything at all to the second one?
And here's the code. It's super simple. The first line creates our object reference on the stack, which points to a brand new calculator object in the heap, maybe at address 101. The second line creates object 1 on the stack, and it points to a different, brand new calculator object in the heap, say at address 105. Two separate objects. Then we use the first remote control, object, to change its num to 8. We don't touch object 1 at all. And what's the output? Exactly what we'd expect. The first object's number is 8, but the second object's number is still 5. Changing one had absolutely zero effect on the other. This is the proof. They're two distinct objects living in two different spots in the heap. It's just like I said before. If you have two identical iPhones and you smash the screen on one, the other one is perfectly fine, right? Same exact principle.
All right, that was a lot to take in. So let's do a quick final recap just to lock in these concepts.
This little table here is basically your cheat sheet. The stack? It's for your local variables and those all-important references. It's small, it's fast, and things there don't live very long, only as long as the method is running. The heap? That's for the actual objects and all their data. It's way bigger, a little slower to get to, and objects can live there for a long, long time. Here's the best way to remember it. The stack holds the map, but the heap is the territory.
So now we know where everything lives, but that brings up one last really important question. We know how to create objects in the heap, but what happens when we're done with them? Who goes in and cleans up that warehouse to make room for new stuff? Who cleans up the mess? Well, that's a fascinating topic, and it's a story for another time.